thermal expansion. Now here we are going to discuss the thermal expansions shown by solids. Now you all know that by heating a metal it is found to expand. So you might have seen if steel glass is put inside another one and if it is stuck with each other, cannot take it out, you will be rolling those systems on the ground for a long time. Or if you immerse this glass halfway in a hot water for some time, you can find that it can be taken out. It is because when the glass is coming in contact with the hot water, it is undergoing a small expansion there. We cannot see that directly, but there is a small expansion taking place. And you might have seen in the summer season, the electric lines, they are metal wires, the electric lines are found to be sagging a lot. Okay? But in winter season, it will be straight almost. So this sagging and becoming straight, it is depending upon the temperature of the surroundings. So there is something happening to the solid material by absorbing or releasing heat. If the size of the solid increases by absorbing heat, then we say there is thermal expansion. And by cooling, reducing the heat energy, the material is found to be showing a reduction in its size. We call it as what we call thermal, contraction. So a body, if it is able to expand by absorbing heat, must be able to contract by releasing heat. It's a symmetric property. Okay? Now, why it is expanding? Because solid substances are made up of molecules, and when you heat the molecules, the movement of the molecules will be increasing. They will be getting more energy for what you say translatory motion, vibratory motion, and also for rotatory motion. So as they start moving with a greater and greater kinetic energy, the spacings between the molecules will be increasing a little bit. And this spacing increase between the molecules will be effectively causing an increase in the size of the body. This is so simple it is. So as you reduce the heat energy, what happens is that the spacings between the molecules will be reducing and it is coming back to its normal state. Further cooling, it contracts further because so there is a small gap that also being reduced by cooling. Molecules come closer and closer, and thereby the size will be reducing a little bit. Now here, for solids, we are going to discuss three different types of expansions. One is linear expansion. Linear expansion. By absorbing heat, the length of the material is increasing. Then we say there is linear expansion. Then superficial expansion. Superficial expansion or surface area expansion. So by absorbing heat, if the surface area is increasing, then we say there is superficial expansion. And the third one is cubical expansion. Cubical expansion. Cubical means related to volume. Meter cube. So cubical expansion means by absorbing heat, the volume of the material is altogether increasing. Then we say there is cubical expansion. Now there is always a doubt possible. Under what condition we can say the length alone is increasing or surface area alone is increasing or volume altogether increases? It's a problem. So we distinguish these three types where it comes and when it comes. Suppose you take a thin long rod. I am taking a thin long rod. This is a thin long rod I am taking. For this particular thin long rod, if I keep it, I can see that the length undergoes some expansion. Because length is the prominent dimension for this particular material. Like that, if I consider a thin sheet of metal, I am considering a thin sheet of metal. So if I consider a thin sheet of metal, and if I keep this thin sheet, the sheet altogether it is going to be expanding. Because the prominent dimension measurable here is what? Surface area. So as I give this thin sheet, the surface area, that sheet altogether is expanding, so surface area is increasing. But if I consider a sphere or a cube, sphere or a cube, and if I keep a cube or a sphere, all the dimensions undergo the equal variation, therefore the volume altogether increases. So where the expansion takes place, on which dimension the expansion is possible, is determined by the initial shape and structure of the material. If it is a thin long rod, linear expansion possible. If it is a thin sheet of metal, superficial expansion possible. And if it is a sphere or a cube, the volume altogether increases. Understood? Okay. Now, to get the mathematical equation for the expansion taking place in each case, we will be experimenting on it and come to conclusions like one. The first conclusion is that the change in dimension is directly proportional to the original dimension of the body. Change in dimension. So if it is expansion, increase in dimension, directly proportional to original dimension. And second one, change in dimension is directly proportional to change in temperature, change in temperature of the body, change in temperature of the body. So if I say increase in dimension, then directly proportional to increase in temperature of the body. So these are the two conclusions we can get from the experiment. So what this defines is that, suppose I take 1 meter long rod and if I heat it to 100 degrees Celsius, So if I am getting almost 1 millimeter expansion, suppose that 1 millimeter expansion is taking place. The same material, same thickness, if I take 2 meters and heat it to 100 degrees Celsius, I can expect almost 2 millimeter expansion. So initial length is more, expansion is small. Possibility of expansion is small. This is the meaning of word. First one. Second one is that 1 meter long rod I've heated to 100 degrees Celsius, 1 millimeter expansion. If I heat it to 200 degrees Celsius, I will be getting more expansion, more than 1 millimeter. So as the temperature increases, more and more increases their temperature, then the expansion also will be increasing. That is the idea you can obtain from